Hi, I'm Agathe, and I'm here to present our work at the intersection between computer vision model explainability and identifying bugs and failures in these models. So as most of us might have heard already, models might suffer from various types of failures. Some can be funny ones, such as confusing whether something is a chihuahua or a muffin, but some others might be much more critical for safety. For instance, this car started to slow down just because it confused the moonlight with yellow traffic lights. And other failures might also pose societal harms, like this vision API that confused thermometers with guns when darker skin color hands would be holding these thermometers. And so these different types of failures are due to different types of bugs, for instance, in the data sets that were used to train the models or in the architecture used for these models. In reaction to that, the machine learning testing community has developed automatic methods to identify these failures and bugs. However, our formative study showed that these methods are typically not used by practitioners. Instead, other works look into the explainability of models, and certain explainability methods are used by practitioners according to our study. Yet, no in-depth study has been performed to show how exactly these explanations are used for debugging. That is what we do in this work. Especially, there are different types of explanations, for instance, based on their medium scope audience, and we don't know which ones are actually useful. For instance, we're looking to local explanations, providing visual indications of the features a model might be using to predict one class for one sample. So these saliency maps. And there can also be global explanations, such as the one from SIGCHI, that provides textual information about features the model might be using generally to classify one image. And so, specifically in this paper, we ask how could diverse explainability methods be used to support the failure identification and bug characterization processes of deep learning computer vision models. And to answer the question, we decided to take a research through design approach and to build a design probe. For that, we first needed to identify the functionalities that the probe should allow for, how they should be realized within the user interface, and what kind of interactions or workflows this interface should be providing. And so to do so, we performed a literature analysis, a formative study, and various co-creation sessions that are discussed in more detail in the paper. And next, we wanted to identify the different potential uses of explainability methods for debugging, so using our probe. So we implemented it and performed various user studies. Results. What does the probe actually look like? So it's divided into multiple tabs, different interfaces, providing different functionalities. Let's see a few of them. For instance, this one provides information about the performance of the model to be debugged. Especially, you can see this confusion matrix. And when you click on a cell of it, you then see explanations related to the classes concerned by the matrix. For instance, here you can see local visual explanations, saliency maps that I mentioned before. But also if you click on one of these images, textual explanations that relate to it. You can also see, of course, global explanations here that show how the model might distinguish between the two concerned classes. Displaying all these explanations in the same interface allow for the comparison between them. And then we have different kind of interfaces for different breadths of explanation. Before it was about 2 classes, and now about all the classes of the data set. So these global explanations with default parameters to compute them, or more variability for someone who is more used to them. You can also have different kind of interactions, for instance, for querying the explanations. or querying even images on which the model was trained. These query explanations, for instance, mimic counterfactuals that some participants of our formative study were asking for. And so now on to the user study. So we provided one use case, bird classification, and we made sure to include different types of failures and bugs in this use case. So depending on whether the model was making correct or incorrect inferences and using correct or incorrect features. And we interviewed 18 practitioners who went through this use case and debugged the model. And then we also gave them post questionnaires based on the user engagement scale and ratings of each interface. We got various results. I will just explain a few of them here. So first of all, we could see that the bug identification process was rather successful with the explanations we gave. In average, participants identified 3.5 bugs. However, the results were quite disparate between participant, type of explanations used, type of background they had. This is because some of them had different views on what a failure is, especially for feature failures, but also because others needed maybe, for instance, more guidance or less confidence in their actual process. Some also misinterpreted the explanations, which led to identify the wrong bugs. So this shows different opportunities for future work in developing better user experiences, providing warnings, for instance, not to neglect certain types of bugs, and providing more guidance in general. We also went into more detail into each of the explanations that were used, and especially identified that they are complementary. Both global and local explanations were used for different steps of the debugging process. And similarly, different medium of explanations were used, visual more frequently, but also textual explanations that were maybe less familiar. The required functionality was also useful, although more advanced and less used functionality. So this again shows avenues for future work, for instance, to develop types of explanations that have been less researched until now. So to think about the extent of automation that one needs for guidance, and at the same time of freedom to actually further identify bugs. So in summary, we provide a design probe first, and then we performed user studies, which gave us insights on the use of different kinds of explanations that are already existing, but also showed avenues for future research opportunities.